Now, in the previous lesson, we looked at gravitational potential energy, and we learned that that is a type of energy in storage. Okay, that's to say, potential energy is energy that is in fact invisible to us. We cannot see it, or our senses cannot perceive that it's there. Well, kinetic energy is a form of energy in action. Yes, we can feel and see and are aware of kinetic energy. So, we've got a 9-pin bowling alley or whatever, and this is a ball which has got a mass m, and it's rolling along the ground at a velocity v. Then we can say that the kinetic energy of the ball is equal to, and that k dot e is for kinetic energy, is equal to a half m times v squared times its velocity squared. Okay, so in kinetic energy calculations, then we can also employ one of those calculation triangles. Okay, which is, there we go, we can write the kinetic energy at the top, and then we'll write the division bar and a half times m times v squared at the bottom. So just in this particular case, if the mass of our ball is 2 kilograms and it's travelling at a speed of 7 meters per second, then its kinetic energy will be equal to a half, and mass is always in kilograms, remember, so you always look out for that in exam questions. You must make sure that you convert grams into kilograms. Examiners will deliberately try and trick you there. So times 2 times the velocity squared, which is 7 squared, that means 7 times 7, right, which is equal to 49, and units, joules. It's a form of energy. So the kinetic energy of an object is dependent upon its mass and velocity. So clearly in these two situations, you've got a car which is travelling faster than the bike and is a lot heavier than the bike. Well, clearly the car will have a lot more kinetic energy than the bicycle. Right, so the heavier the object, the faster it's travelling, the more its kinetic energy. So let's have a look at another type of problem. Just say that this cyclist here, the combined mass of the cyclist and bicycle is 90 kilograms. Let's just say we're told that the kinetic energy of the cyclist and bike at this moment is 4,500 joules. Okay, and you've got to work out his or her velocity. Okay, so you write out the formula first of all. That's the first step. Kinetic energy equals a half mv squared. And let's suppose you're not particularly confident about using rearranging expressions, so you write out your triangle here, your calculation triangle. You know that what you're after is the velocity, right? So you cover up the v squared there, and then you rearrange your expression in the form that you want. So that means you write v squared is equal to kinetic energy divided by a half times m. You substitute your values in, which gives us 450 divided by a half times 90, which 4,500 divided by 45 equals, conveniently, surprise surprise, 100. So what you need to be able to do here, to find v, you need to take the square root of 100, right? And that comes out as 10 meters per second. So in the next lesson we'll look at the transfer of gravitational potential energy to kinetic energy and back again.